Normal medicine says cancer is defined by cellular pathology, meaning if you have a suspicion that somebody has a cancerous growth somewhere in their body, and that suspicion can be provoked by feeling a tumor, like in the breast or in the prostate with a prostate exam, or you might see it on some sort of scan, like a CT scan, or you might see it during an examination of like a colonoscopy, or you might even suspect it with a blood test like a PSA. So you go from I would say, a clinical suspicion or a laboratory suspicion or a scan suspicion, and then you look for a abnormal collection of cells, and then you take those cells out of the body and you look at them under the microscope, and if they have a certain characteristics, particularly the chromosomes in the nuclei of the cell are abnormal, then you say this person has a cancer, and then you basically type it as to where the tissue came from. So if it came from the breast, then you have a breast cancer, and then you do biochemical analysis and you say it's an estrogen or positive or whatever kind of breast cancer. In my book, what I proposed is that there's two fundamental characteristics of cancer. If you look at a cancer, what you feel is that the tissue feels differently than the surrounding so-called healthy tissue. And again, this isn't any great, brilliant conclusion, it's just simple observation. In other words, if you take an example of a breast cancer, you feel a person's breast and it feels normal, soft and flexible, and then you come to this lump and it feels like a hard rock was put into this otherwise normal tissue. That's all I mean by it feels different. And that's universal in basically all cancers, with the exception of blood cancers, which is a little bit different. So the first thing is cancers feel differently, and then I can explain why. And then second, if you do look under a microscope, you see that the nuclei, the chromosomes, are distorted. That's one of the hallmarks of cancer. In other words, it's called aneuploidy, meaning that normal cells have a certain number of chromosomes and that cancer cells have a different number of chromosomes, which means they're actually different species, because we define species as based on the number of chromosomes. Humans have 46 and elephants have whatever number they have, and that's how we know it's an elephant cell. Humans have their number, but cancer cells have an abnormal number, and so those two things together, when you see an abnormal number of chromosomes in a tissue that doesn't feel and look like the normal tissue, that's what we call cancer.